Welcome to SSR Pharma Media, your trusted source for pharma knowledge. So, PIC and Pharmaceutical Analysis PA MCQ series, your exam power boost. So, Pharmaceutical Inorganic Chemistry and Pharmaceutical Analysis. So, in that, we are going to discuss about non-aqueous titration. So, non-aqueous titration is present in both Pharmaceutical Inorganic and Pharmaceutical Analysis subjects. Prepare, practice, succeed. Under the non-aqueous titration, today we are going to cover what is non-aqueous titration and interference due to water in non-aqueous titration, and types of solvent used in non-aqueous titration, acidimetric and alkalimetric titration using non-aqueous solvents, and preparation and standardization of acidic and basic titration of non-aqueous, and estimation of weakly acidic and weakly basic substance using non-aqueous titration. So, we are going to cover these topics. So, in non-aqueous titration, what is non-aqueous titration? Non-aqueous titration is used for assay of weak acids and weak bases that cannot be accurately titrated in water due to poor solubility in water, weak dissociation in aqueous medium, side reactions or instability in water. So, due to these reasons, we are going for non-aqueous titration. So, non-aqueous, aqueous means water, non means without water. So, without water, we are going to estimate the purity of the weak acids and weak bases of drugs. In non-aqueous titration, use solvents other than water to enhance the strength of acids and base and improve titration endpoint. Interference due to water in non-aqueous titration, when weakly basic drug is present. So, when weakly basic drug is present in water, suppose if it is present means water, when it dissolves in any acids or base, it dissociates H plus and OH minus ion. So, it acts as both as acidic character and basic character. Waters have both acidic and basic character. So, when weakly basic drug is present, so water containing OH minus ion act as a strong base and preferentially accept protons from an acid. So, thus there is interference in the reactions of weak base with an acids. And same like that, when weakly acidic drug is present, so water containing H plus ion behaves like a strong acid. So, preferentially donate proton to the base. So, thus there is interference in the reactions of weak acids with base. So, water H plus ion act as a acid, OH ion act as a base. So, due to this interference, waters cannot be used in this non-aqueous titration. Hence, in the presence of water, titration of either weakly acidic substance with a strong base or weakly basic substance with strong acid is not possible. Move into the MCQs. Non-aqueous titrations are primarily used for the assay of, so option B is the answer. It is used for the assay of weak acids and weak bases. Non-aqueous solvent improve ionization and it leads accurate titration. The main reason for using non-aqueous solvent is, so option B answer, to increase dissociation of weak acids and base. So, non-aqueous solvent enhances the proton donor or proton acceptor ability, which increases dissociation of poorly ionized substance. Types of solvent used in non-aqueous titration is a very important topic in non-aqueous titration. So, there are 4 types of solvents are mainly used. That is called aprotic solvent, protophilic solvent, it is also basic nature, and protogenic solvent, it is acidic nature. Ambiprotic solvents, it has both acidic and basic characters. So, what is protophilic aprotic solvent? So aprotic solvent means it is do not donate or accept proton, and it has low dielectric constant. For example, benzene, toluene, chloroform. So aprotic is nothing but it does not contain hydrogen ion. H plus ion will not present in that solvents. So like toluene, that means it will not donate. Benzene, it has H plus ion, but it will not donate the hydrogen ion. Toluene, and chloroform doesn't have the hydrogen ion. So these solvents are called as aprotic solvent. Aprotic solvent means in the sense you must understand two things. One does not have hydrogen H plus ion. In another sense, it does not donate the hydrogen ion. Suppose if it is has also, it will not donate the protons. So such solvents are called as aprotic solvents. So it is used in the titrations of diluting solvents and enhance the ionization. And protophilic solvent is also called as basic solvent. Philic means is allowing or abstract the protons. Proton acceptor. It is also called as proton acceptor, which increase the acid strength. It is for example, pyridine, DMF, dimethyl fluoride, ammonia, aniline. So these are all is example for protophilic basic solvents, and it is used in the acidometric titration of weak acids. Protogenic solvent means is acidic. Genic is it is used as a type of acidic solvent. It is also called as proton donor, which increases the base strength. And example, formic acid, sulfuric acid, nitric acid, and HCl. So hydrochloric acid. These are all called as acidic solvents. And it is used in the alkylimetric titration of weak bases. And amphiprotic solvent, so which can donate and accept proton. It behaves as a basic, and it has basic and acidic character. Both character it contains amphimetric. So it can donate proton, that means it is acid, can accept proton, it is called basic in character. Example, methanol, ethanol, water, and acetic acid. So these two donate a proton as well as accept the proton. So it is used in the titration, mixed solvent titrations, and buffer system, also used as a buffer system. Glacial acetic acid is classified as which type of solvents? So option C, protogenic. Glacial acetic acid means it is a amphiprotic solvents. It is not a, it is a type of amphiprotic solvent because it donate a proton and donate glacial acetic acid is CH3 COOH. So after donation it forms CH3 COO minus and plus H plus ion. It donate the proton. So it is a acidic in character. At the same time it accept the proton. When it's accepting, it's convert into acetonium ion CH3 COOH2. So it is called acetonium ion formation takes place. So it is a amphiprotic in nature. So it has both acidic and basic in character. So answer is, so option D is the correct. Which of the following is a protophilic solvent? That means it's a basic solvent. So the answer is option A, pyridine. So pyridine is to donate a proton, accept the proton, proton acceptor. Methanol is the best classified as, so option B, amphiprotic solvents. It has both basic and acidic character. Aprotic solvents are primarily used for, option B, diluting medium. So non-reactive because it does not containing proton donors or may not contain protons, or it may not donate the protons. So such solvents are called as aprotic solvents. So it is used as a diluting medium. It's a non-reactive diluents. Which is an example of one aprotic solvents? So option C is a benzene, is a type of aprotic solvents. Aprotic solvent means which do not donate or dissociate the protons. So, does not donate or accept proton. Next is, it is a very important topic, leveling solvents and differentiating solvent. So, it's a very important topic. What is leveling and what is differentiating solvents? So, protophilic solvents is also called as basic solvent. It's a philic means is a loving. Loving is nothing but abstract. That means accept the protons. And these are all the example, pyridine, ammonia, anilines and all. It's mainly used in the weak acid titrations. So, in protophilic, basic solvents are two types, strongly basics and weakly basics. There are two types of basic solvents are there. So, strongly basic solvents act as a leveling solvent. It is a type of leveling solvent. For weak acids and strong acids are used in the titrations. So, it can abstract or it accept the proton from any weak acids and strong acid. So, it acts as a leveling effect. And weakly basic drugs, it is also called as differentiating solvents. So, differentiating solvent means it is tendency to accept, first of all, weakly basic means it's accept the proton. It's a weak tendency to accept the proton and can abstract proton from strongly acidic substance, not from the weak acids. So, here it is a differentiating. So, it is a, even though it is basic, so it will not accept the proton from either weak acids or strong acid, weak acid. So, it can ability have differentiate whether it's strong or base. So, only it will accept the protons from strongly acidic substance only, not from the weakly acidic substance. So, it is also called as differentiating effect. So, differentiating effect means it can accept the protons only from strong acids. So, it is called differentiating effect. But leveling effect means, so it can abstract proton from weak acids or strong acids. So, in order to equilibrate, it will abstract either weak acids when solvents are too basics. So, it accept the protons from strong acids, and if solvents are highly acidic, it accept from the weak acids. So, it can it both from both weak acids and strong acid it accept in order to make the equilibrium, that means leveling. But here not, it accept only from one side. So, a differentiating effect is more likely to be observed when using option C, it's a weakly basic solvents. Protophilic solvents exert a strong leveling effect on option C, it's a strong acid. Which of the following is the commonly used protophilic solvent in non-aqueous titration? So, option D, liquid ammonia. So, liquid ammonia is a highly protophilic, that means highly strong base. So, it is excellent proton acceptor. It shows significant leveling effect for strong acid. And it is a classical example of non-aqueous titration, non-aqueous acid based system. Perchloric acid in glacial acetic acid is used to titrate weak bases because, so option B is a glacial acetic acid enhances the differences between bases. Next, estimation of weakly acidic and weakly basic substance using non-aqueous titration. So, there are two types of titration, acidimetric titration and alkylimetric titration of non-aqueous. And here in acidimetric titration, example of in acidic metric, basic drugs are used, weakly basic substances are used to determine its purity, like diphenhydramine, ephedrine and chlorpromazine and chlorpromazine. And for weak acidic substance, example allopurinol, mercaptopurine, nalidixic acid, phenobarbital, 5-fluorouracil phenytoin. So these are all the weakly acidic substance is used in the alkylimetric titration to determine its purity. And in acidimetric titration, direct titration of primary, secondary, tertiary amines or purities are determined. Titration of halogen acid salts of weak bases also determined. And in acidic titration, perchloric acid in glacial acetic acid is used as a titrant. That means it's a burette solution. And 0.1 and perchloric acid preferably used. In basic titration, sodium methoxide in methanol is used as a burette solution. And 0.1N sodium methoxide used to determine the allopurinol, mercaptopurine, and 0.1N potassium methoxide and also may used, and 1N lithium methoxide, 0.1N lithium methoxide also used for the nalidixic and phenobarbital, and 0.1N tetrabutyl ammonium hydroxide for the estimation of 5-fluorouracil and phenytoin it's used. So very important. So there are 4 type of burette solutions are used here. 0.1N sodium methoxide, 0.1N potassium methoxide, 0.1N lithium methoxide, 0.1N tetrabutyl ammonium hydroxide. But in acidimetric titration, only 0.1N perchloric acid is used. And in the preparation and standardization of this titrant of burette solution, in acidimetric 0.1N perchloric acid, it is prepared in using glacial acetic acid as a solvent. Preparation, first 0.1N perchloric acid and glacial acetic acid. Preparation you have to prepare and use potassium hydrogen phthalate in glacial acetic acid as a standardizing primary standard to determine the purity of perchloric acid. Indicator, crystal violet indicator is used. Here color changes from emerald green, violet color to emerald green color change. And in the alkylimetric titration, base titrant is sodium methoxide in methanol, 0.1N sodium methoxide is prepared, and benzoic acid is used in dimethyl formamide solution for standardizing the 0.1N sodium methoxide, and indicator phenolphthalein azo violet is used. So precautions of while preparing the perchloric acid, we must do with the precautions, because during the preparation of perchloric acid is diluted with acetic acid, and then the acetic anhydride must be added. Only small volume, nearly 30 ml of acetic anhydride must be added. Otherwise, the formation of acetyl perchlorate, which is explosive in nature. That means when we are preparing the perchloric acid, first perchloric acid is diluted with acetic acid. So after that, we must add 30 ml of acetic anhydride. Before we should not add, before only with perchloric acid, we should not add this acetic anhydride. If we are adding the acetic anhydride, only perchloric acid alone, it forms acetyl perchlorate, which is explosive in nature. So after diluting with glacial acetic acid only, we must add acetic anhydride. So the reason for adding acetic anhydride is, so if it is a type of non-aqueous, so any 1 or 2 water molecule, suppose if it is present, so that water molecules are masked with this acetic anhydride to interference in the titration. The water may contain H plus ion and OH minus ion, so this may interfere in the titration. So in order to prevent this, so acetic anhydride is added to remove the moisture content. In non-aqueous titration, acetic anhydride is added during perchloric acid preparation. Perchloric acid in glacial acetic acid is used for titration of Option C, weak bases. Sodium methoxide in methanol is used to titrate. Option A, weak acids. Crystal violet is commonly used as an indicator in non-aqueous alkalimetric titration. Which solvent system is most commonly used in non-aqueous titration? So option C, glacial acetic acid. In alkalimetric titration using sodium methoxide, which indicator is preferred? So option C, phenolphthalein. During the preparation of 0.19 perchloric acid in glacial acetic acid, we must add acetic anhydride added after initial diluting perchloric acid with glacial acetic acid. Why? So option C, to remove water and prevent formation of explosive acetyl perchlorate. The primary standard used for standardization of perchloric acid in glacial acetic acid is, so option C, potassium hydrogen phthalate. Sodium methoxide solution is commonly prepared using, so option A, sodium metal plus methanol. Standardization of sodium methoxide is performed using, so option B, benzoic acid is used as a primary substance. Which of the following can be estimated using sodium methoxide? So option C, allopurinol. Which of the following can be estimated using perchloric acid? So option A, ephedrine. Indicators used in non-aqueous titration except starch. So crystal violet is used, quinaldine red is also used, thymol blue also used. So starch is not used. The answer is option D is the right answer, because starch is used in the redox titration. The redox titration it is used, not in the non-aqueous titration. So non-aqueous titration, so these are all the indicators are used. Why mercuric acetate is added in titration of halogen acid salts of weak bases? Halogen acid salts of weak bases include compounds like ephedrine hydrochloride, diphenhydramine hydrochloride, lidocaine hydrochloride. So these exist as BH plus Cl minus, where B is a weak base and Cl is a halogen counter ion. So during titration with perchloric acid in glacial acetic acid, the presence of halide ions interferes with the indicator and the reactions. So may affect the endpoint. So in order to prevent that interferences, we are adding mercuric acetate. So mercuric acetate is added to convert interfering halide ion like chloride, bromide, iodide into stable mercury halide complexes. So it forms the mercury chloride, mercury bromide, mercury iodide. This prevents halides from acting as a weak bases in glacial acetic acid and eliminates formation of HCl and ensures a sharp, accurate endpoint in the titration of halogen acid salts of weak bases. So mercuric acetate liberates equivalent quantity of acetate ions. It can be quantitatively estimated by titrating with perchloric acid. Mercuric acetate is added during the non-aqueous titration of halogen acid salts of weak bases, mainly used to, so option B, precipitate halide ions as insoluble mercuric halides. So read this content. Which drug can be assayed by perchloric acid in perchloric acid? Which drug can be assayed by perchloric acid in perchloric acid? So answer in the comment box. Thank you. So all of you join in our WhatsApp community. You will get number of hands-out material and number of test series. So thank you. Like, subscribe and share.